Welcome. My name is Tiearea Sims. I'm a doctoral student at California Intercontinental University, and today I will be doing a presentation on analyzing correlational data. The agenda for this presentation will be to explain what a significance level is, to explain the purpose of a p-value, to present null and alternative hypotheses for data being correlated, and to identify significant results of 6 correlational data tests. The significance level, also known as the alpha or A, is the probability of rejecting the null hypothesis when it is true. For this correlational study, I used a significance level of 0.05 that would indicate there is a 5% risk of suggesting that a difference exists when there may not actually be a difference. P-values are the probability of obtaining an effect at least as extreme as the one in your sample data, assuming the truth of the null hypothesis. For this study, a two-tailed approach was used to identify positive and negative extremes. Data analyzed for this study included income and debt, income and savings, income and stocks, income and wallet, debt and savings, debt and stocks, debt and wallet, savings and stocks, savings and wallet, and stocks and wallet. The first hypothesis test correlated income and savings, with the null hypothesis being income has no effect on savings, and the alternative hypothesis being income does have an effect on savings. The correlation coefficient and its p-value were calculated using SPSS software by IBM, assuming a significance level of 0.05. A significant correlation emerged as a result, with the correlation coefficient being 0.90 and the p-value being 0.00. The test rejected the null hypothesis and concluded there was a correlation between income and savings. The second hypothesis test compares income and stocks, with the following null hypothesis. Income has no effect on stocks obtained, and an alternative hypothesis saying income does have an effect on stocks obtained. SPSS was again used to calculate this data and showed a correlation coefficient of 0.194 with a p-value of 0.018. This test rejected the null hypothesis and concluded that there is a correlation between income and stocks. The third hypothesis test compared income and the amount of money that people had in their wallets. The null hypothesis for this comparison is there is no correlation between income and money in wallet. The alternative hypothesis is there is a correlation between income and money in wallet. Again, SPSS was used to calculate the data with a significance level of 0.05 that showed a correlation coefficient that was equal to 1 and a p-value of 0.00. This test rejected the null hypothesis and concluded there was a correlation between income and the amount of money in the person's wallet. The fourth hypothesis test compared savings and stocks with the following null hypothesis. Saving has no effect on stocks obtained, and an alternative hypothesis saying savings does have an effect on stocks obtained. Again, SPSS software was used to calculate data with a significance level of 0.05. As a result, a positive correlation was shown at 0.284 with a p-value of 0.00. This test rejected the null hypothesis and concluded there was a correlation between savings and stocks obtained. The fifth hypothesis test compares savings to money in wallet, with a null hypothesis saying there is not a correlation between savings and money in wallet, while the alternative hypothesis says there is a correlation between savings and money in wallet. SPSS was again used to calculate this data, assuming a significance interval of 0.05. The correlation coefficient shows a positive correlation of 0.908 with a p-value of 0.00. This test rejected the null hypothesis and concluded there was a correlation between savings and money in wallet. The sixth hypothesis test compares stocks and the amount of money available in a person's wallet, with a null hypothesis of ownership of stocks has no correlation with money in wallet, and an alternative hypothesis of ownership of stocks does have a correlation with money in wallet. SPSS was again used to calculate this data with a significance level of 0.05. The results showed a correlation coefficient of 0.194, which is slightly positive, and a p-value of 0.017. This test rejected the null hypothesis and shows there is a correlation between ownership of stocks and money in wallet. So remember, the significance level, or alpha, is the probability of rejecting the null hypothesis when it is true. The p-value is the probability of obtaining an effect at least as extreme as the one in your sample data, assuming the truth of the null hypothesis. And correlations are significant when r is not equal to 0 and the p-value falls within the significance level. Thank you for reviewing my presentation. Please feel free to ask any questions if you have them. Thank you.